Good afternoon. The problem asks us to rank the power output of each of the following resistors from greatest to least. It being a combination circuit, we're going to combine certain resistors to find their equivalent resistance. We start with a grid below with our voltage, current, resistance, and power as listed. We can now put in our values that we know. We know that resistor 1 is 25, resistor 2 is 60, so on, and that our total voltage is 120 for the circuit. If we start by combining resistors 3 and 4, we see that they're in series so that we can combine them simply by adding. And when we add the 5 plus the 15, we get an equivalent resistance of 20. Our next step would be combining resistors 3 and 4 that are in series with resistor 2 that is now in parallel. So essentially we have a 20 ohm resistor in parallel with a 60 ohm resistor. In order to find the equivalent resistance of that, we're going to find 1 over 20 plus 1 over 60 equals 1 over RT, or the total resistance. And we see that that total resistance of resistors 2, 3, and 4 is equivalent to 15. Now we have resistors 1, the combinations of resistors 2, 3, and 4, and resistor 5 all in series. So now we can simply add those as if they're all in a series circuit, which they are. We now take the 25 plus the 15 plus the 20, and we get an equivalent resistance of 60. So our total resistance within the circuit is now 60 ohms, which we can put here in our total column. Using Ohm's law, if we know the voltage and we know the resistance, we can determine that the current is 2 amps. Also, from our series circuit ideas, we can now say that that 2 amps is going through resistor 5 and resistor 1 as well. Likewise, the combination of resistors 3, 4, and 2 also experiences 2 amps. However, each individual resistor does not experience 2 amps. Labeling, we can now see what we have in our total circuit. Using Ohm's law once again, we can now find the voltage drop over each of these individual resistors, R1 and R5. Likewise, we can find the total resistance drop across the combination of resistors 3, 4, and 2. Invoking the parallel circuits law, we can now see that we have 30 volt, a difference of 30 volts across resistors 3 and 4, and likewise across resistor 2. Once again, invoking Ohm's law, we can find that the current through resistor 2 is going to be 0.5 amps. And the current through resistors 3 and 4 will be 1.5 amps. Using the series circuit law, we can see that the current through both resistors 3 and 4 are going to be 1.5 volts, and now we can use Ohm's law to find that they have a voltage drop of 22.5 and 7.5 respectively. Once again, labeling our diagram. From this point, we can now easily find our power for each of the resistors by simply taking the voltage times the current. If we do that for our total circuit, we should find that our power is 240 watts. 140 volts times 2 amps should give us 240 watts. And our power should be a sum of all the powers of the resistors. If we add those 5 resistors, we get 240 watts, which checks with our total. Now it's simply a matter of ranking the power outputs. R1 is greater than R5, which is greater than R4, which is greater than R2, which is greater than R3. And at this point, we have answered the question of ranking the power output of each of the following resistors from greatest to least. Thank you.